In this section, 8.6, we're going to look at financing cars. So a car loan is usually what we call a fixed installment loan. So that would be a loan that's paid off in fixed monthly payments. And the loan payment formula would be given by this formula below, the PMT formula. It has all the usual values that we have from the annuity formula, except for the PMT, that would give you your regular monthly payments for your car loan. R is still the interest rate. T is the years that you're going to have your loan. P is the amount that you borrow, so that would be the cost of the car. N would be the number of payments per year. Example 1, Blessing is going to borrow $30,000 to purchase a new truck. She has two loan options. Installment loan A would be a 3-year loan at 6% interest. Installment loan B would be a 5-year loan at 8% interest. So we want to, in Part A, find the monthly payments and total interest paid for loan A. And the same for Part B. Part C, we're just going to compare and discuss the two options. So first of all, in Part A, let me figure out what the payment would be. So the monthly payments would be, again, be careful how you put this in your calculator. 30,000 is the P. R, the interest rate was 6%, so that would be a 0.06 divided by N. Since it's monthly payments, N is 12. All over 1 minus, in parentheses, 1 plus the interest rate of 0.06 over the N, which is 12. And that's going to be raised to the exponent negative N times T. So negative N was 12 times T in this case is 3 for the 3 years. So when I put that in my calculator, I got 912.6581235, but I'm going to round it to the nearest dollar and write 913. So that would be the payments. The interest is going to be how much money you put in, and then we'll subtract the loan amount of $30,000. So the payments are $913. We're given 12 payments a year, so times 12. The total loan is for 3 years, so times 3. In a calculator, that's going to give me 32868. So that's how much money we've paid total for this car that costs $30,000. So if we subtract the $30,000, which is the price of the car, what we get is $2,868. So we have our payments per month would be $913. The total interest we pay once we've paid the car off is $2,868. Now let's compute B, loan B. Our payments would be equal to still 30,000. And this time the interest rate is 8%. So 0.08 over, still going to do monthly payments over 12, divided by 1 minus parentheses 1 plus the interest rate of 0.08 over 12 for the monthly payments, raised to the power of NT, so 12 times, and this time the loan is good for 5 years. When I put that in my calculator, I get 608.2918286, which I'm going to round to the nearest dollar and write 608. Just be careful in my lab. Sometimes they'll want you to round to 2 decimal places to represent not only the dollars but the cents as well. So just be careful about rounding there. The interest is going to be the total amount paid, which would be $608 per month, so times 12. And then this loan is for 5 years, so times 5. In my calculator, I get 36480. When I subtract the 30,000, I get 6480. So the monthly payments are $608, and the total interest paid once the car is paid off is $6,480. Now this is going to really bug me. If I look at part A, I'm going to put a little arrow here because these are really not equal values. And part B, sorry, notation bugs me. Okay, so part C, compare and discuss the two options. Well, sure, part in B, loan B, the payments are lower, but you're paying total of $6,480 in interest by the time you've paid off the car. So cost-wise, the better option would be A. And the reason being is that you pay much less interest. So when you think about the total amount you actually did pay for the car, which would be the loan amount plus interest, loan A, you paid $32,868 total, and loan B, you've paid $36,480 total. So you had lower payments, but since it was stretched out for a longer period of time, you ended up paying more in interest. So the better option is loan A. So now we're going to do a little bit of vocabulary. One option you have instead of purchasing would be leasing a car. So when you think of leasing a car, leasing is a rental agreement. It's like you're renting the car, and there's two basic types of leasing contract. The first type would be a closed-end lease. So that's where you just do monthly payments, and at the end of the lease, you pay for mileage in excess of what you estimated your mileage would be. An open-end lease is a little bit different. So you make payments based on the residual value of the car. So the residual value is the estimated resale value of the car once your lease is over. When you return the car, if at the time you return it, it's appraised less than the residual value, then you pay the difference. If it's appraised greater than or equal to the residual value, then you owe nothing, and you may even receive a refund depending on the lease agreement. So there are some advantages to leasing. You have a small or no down payment. Lease payments are typically lower than loan payments. You return the car so you don't have to worry about selling or maintaining an older vehicle. The disadvantages of leasing: when the lease ends, you have no car. Most lease agreements have mileage limits, so that if you exceed the mileage, you get charged quite a bit. So while leasing, you're usually responsible for all the maintenance anyway, as if you own the car. So that's usually not covered under a lease agreement. And if you decide to terminate your lease early, there's usually penalties. Something else that comes up when we talk about cars is auto insurance. So if you do own or lease a car, you do need to purchase insurance. So that would give you protection, against unforeseen events. The one that's required in most states, so it just depends on the state you're in, is liability insurance. So Hawaii has that requirement. And there's two types of liability insurance: bodily injury liability. So that would cover the cost of lawsuits in the event, typo, this should say in the event someone is injured or killed in an accident in which you are at fault. The other type would be property damage liability. So that covers damage to others' cars. Gosh, who typed this? I think I need a secretary. Other cars. And property from negligent operation of your vehicle. If you have a car loan or you lease a car, you'll also need collision and comprehensive coverage. Okay, this is getting ridiculous. Coverage. So collision coverage pays for damage or loss to your car if you're in an accident, and comprehensive coverage pays for damage or loss of a car due to perils such as a fire, theft, or acts of nature. So the question becomes, if you do purchase a car, will you go new or used? Well, depends. A new car loses an average of 12% of its value the moment it's driven off the lot. A used car that is 2 or 3 years, okay, may be a better buying option. So it has a lower price tag. The depreciation is greatest in the first few years. So once you've gone past the 2-3 year mark, the depreciation sort of just levels off and it's not so bad. Financing is available for cars less than 5 years old, and a reputable dealership will offer an extended warranty. So let's do an example where we compare a loan for a new car versus a used car. Example 2, Bo is thinking about buying a car and has narrowed it down to 2 options. A new car that costs $30,000 with a 4-year loan at 7% interest. A used car, same model of car, but it's 3 years old. It costs $18,000 with a 3-year loan at 8.5% interest. So what would be the difference in the monthly payments? So again, we're going to use this payment formula. If we look at the new car, the payments would be, it's a $30,000 loan, so 30,000 times R, in this case R is 7%, so 0.07. Monthly payments would be divided by 12 over 1 minus parentheses 1 plus the interest rate, which is 0.07 over the monthly payments, 12 raised to the exponent 12 times 4, because it's a 4-year loan. And now that would be about $718 is what I got in my calculator. The used car payments would be $18,000 is the loan amount, times the interest rate here is 8.5, so it's going to be 0.085. Monthly payment, so N is 12. And then we divide by 1 minus parentheses 1 plus the interest rate, 0.085 over 12, raised to the negative 12 times, this is a 3-year loan, so 3. And then I have 568 if I round to the nearest whole number. So comparing these two options, we have monthly payments of $718 versus $568. The difference is going to be $150 per month. In this particular problem, we were only asked to look at the difference in monthly payments. So the used car has lower payments. So there's also expenses if you own or even lease a car. So cars are very expensive to operate and maintain. The average yearly cost to own and operate a car is about $9,000. So in this table is in your textbook as well. In this table, it gives the average cost per mile for different types of cars. So for a small sedan per mile, it would be about 45 cents to maintain the car, which would be about $6,729 per year. And then we have the same for a medium sedan, minivan, SUV with four-wheel drive, and a large sedan. We also have the cost of gasoline if you want to compute your fuel. So your annual or yearly fuel expenses is going to be the yearly miles, total miles that you've driven, divided by the miles per gallon. Once you get that, then you would multiply it by the price per gallon for the gasoline. Example 3, we're going to suppose that you drive 20,000 miles per year and gas averages $3.80 per gallon. Part A, what would you save in annual fuel expenses if you drive a hybrid averaging 50 miles per gallon rather than an SUV averaging 18 miles per gallon? So let's figure out part A first. Why don't we look at the hybrid? So remember, we're supposed to be finding the annual fuel expenses. So that would be the cost of the gasoline. With the hybrid, it's going to be the annual miles driven. And we were given that it was 20,000 divided by the miles per gallon. We were told that that would be 50 miles per gallon. And then we're going to multiply that by the price per gallon, which is $3.80. That should be 1520. And now for the SUV, it's also 20,000. However, miles per gallon is going to be 18. And then we'll multiply that by the price per gallon, which is $3.80, which would give us 4222. So clearly it costs more to in fuel for the SUV than it does for the hybrid. So let's compare them. So the savings with the hybrid would be 4222 minus 1520, and it's quite a bit. It's $2,702. That would be your yearly savings. Moving on to part B. If you deposit your monthly fuel savings at the end of each month into an annuity that pays 7% compounded monthly, how much would you have saved at the end of 5 years? So this is going back to the previous section. So remember this 2702, that's a yearly savings. So monthly, we would have to figure out how much we saved per month, which would be the 2702 divided by the 12 months. And that would be $225. So if we put that $225 into an annuity, so we'll go back to our annuity, and here our T is going to be 5 years, and N is going to be 12 because these are monthly payments. The interest rate R is 7%, so the annuity would be, P would be 225, our monthly payments, and then 1 plus the interest rate of 0.07 over 12 would be our N. The exponent is 12 times 5. Subtract 1 from that. Divide all of that by the interest rate 0.07 over the monthly payment, and which is 12. Putting that in our calculator, after 5 years, we would have saved, rounded to the nearest home dollar amount, would be 16108. So the money saved would be about $16,000 if we were to put that fuel expense away. This is a fairly short section, and that's it for this section. In the next section, we're going to move on to mortgages.